Hello there. Alright, so in today's video we'll be talking about globals and memory. And to start off, I didn't write much code this time around. We just have a wrapper module, and I'm importing this print function from JavaScript, which it's just doing a document.writeLine. And what this will do is we'll just write in the HTML itself. It won't write in the console, so just for conveniency, so we don't have to open the console. Okay, and yeah, the HTML, just usual, not much to see. Now, okay, let's get into it. So what I'll do is I'll create a global. I'll give it a value. I'll give it a name of G, and it'll be a type of i32, and its value will be an i32 constant of 1. Okay. So this is one way to create a global variable. You're creating it directly within WebAssembly, and you're just using it there. Now, another way to create a global variable is to create it from JavaScript. So what you can do is you can come to your import object, you can say G1, and create a new WebAssembly.global, and now you're going to create a JavaScript object with two properties, value, which will be an i32, and another property, mutable, which will be set to true. Okay. Other than that, you just set its initial value, which will set to 1, 2, 3. Okay. Perfect. Now back to our WebAssembly text format. I'll create another global, call it G1. And know that I'm doing this before G because it has an import, so it has to happen before. And we'll say import it, then again our two namespaces, JS, I think I called it G1, and we'll say mute i32. If you're coming from Rust, you know this, but if not, mute just stands for mutable, which you saw in the import object, which just means that the variable can be changed. Okay. Perfect. Now I'll just write quick getter and setter methods, so I'll be right back. Perfect. So what I'm doing is I have this getter method, which is just getting our G1. Note the syntax global.get, pretty similar to local.get. And then we call our print, and in here it's my setter method, so I'll be passing into a value into this parameter. We'll get it, and we'll set it to G1. So it's getting the last value from this tag, which will be this one. Then we call G1 just so we can print it. Perfect. Now in our JavaScript, let's actually call these functions. So we'll say result dot instance dot exports dot get G1, and then we say result dot exports dot set G1, and we'll set it to, what was the initial value? 1, 2, 3. We'll set it to 1, 2, 3, 4. Okay. Now in the terminal, let's run it. Perfect, we didn't get any errors. Now the server is running. Go back in here. You can see the remains of when I was testing the code. But if you run it, we see our initial value. So 1, 2, 3, which is being called from when we first get G1. And then we set it to 1, 2, 3, 4, and we call in the print function again. And we see 1, 2, 3, 4. So that's working perfectly. And we can move on to memory. Alright, so memory. Its name might be a little bit less intuitive than globals, but don't let it scare you. Pretty much it's just an array. And we need this because it will allow us to say, we'll have a more useful print function. We could use it to actually make a hello world example. So that's pretty neat. And yeah, so the way that you define memory is you just say memory 1. Now what this is doing, 1, it's saying that we want to create a memory with an initial size of 1 page. and one page in WebAssembly documentation means that it's 64 kilobytes. Okay. But this is not set in stone. As I'll show you later, you can grow the size to make it bigger. We can only have one memory per module, so I'll comment this one out, and I'll show you how to create it from JavaScript and import it in. So let's go to JS. Let's add a comma here, and we'll say mem, and we'll create a new WebAssembly.memory. Now we create a JavaScript object with property initial, and we set our initial size, which again will be just one page. Perfect. Now in here, I'll just say import JS mem, and I'll put it into a memory one page. Okay. Nice. Now I'll just create a method to populate this memory and another one to get at a certain index, and I'll be right back. Okay, so what I'm doing here, I'm setting the value 123 to index 0, and I'm setting the value 1230 to index 10. I32 store is what's well, storing these values onto memory. And this is our populate memory method. In here, creating this get at, which will receive an index. We'll get this index, and we'll load the variable, the value in this index. And then we call print, just so that we can print it onto our HTML page. Okay. And yeah, so now let's go back to JavaScript and let's call our functions. So we'll say exports dot. So we'll first populate memory, and then we'll say get at, and we'll get at 0, so this should print 1, 2, 3, and we'll get a 10, and this should say 1, 2, 3, 0. So now let's compile. We didn't get any errors, that's good. And let's start our server. Let's go back to Google Chrome. And perfect, we get 1, 2, 3, and 1, 2, 3, 0. So yeah, that's about it. I hope you enjoyed this video, and I'll see you around next time. Actually, I'm back. I realized I forgot to show you how to grow memory, so I figured I'll just make a quick aside. Okay, so let's print our current memory size. I'll do a right line, and let's get our memory. So I'll say import object JS mem. Now our mem object has a buffer property, and the buffer property, we can get its length with byte.length. Okay, so this will print our 64 kilobytes, and yeah, so now, and then we'll print right after, and then in the middle we'll get this memory, and we will pretty much just grow by 1. So what this is doing is just growing by 1 page, which means that it will be duplicated size. So let's just save it. The server is running. Let's go back here, reload the page, and we see this value. This is our 64 kilobytes, and this is double of this. So we have 128 kilobytes. So that's about it. And now for real, I'll see you next time.